Hello friends, so this is the third question which we'll be discussing about Millmans theorem. So here we have this circuit here and we have to find out this current flowing through this circuit, this load resistance RL, which is equal to 20 ohm. So here there is an important thing, an interesting thing, which is that in this branch, this 12 ohm resistor branch, in this part there is no voltage source. So how we will deal with this? Okay, so we'll be using Millmans theorem to find out the Thevenin equivalent circuit. Okay, so excluding the 20 ohm resistance, the Thevenin equivalent circuit will be like this. Okay, this is 20 ohm, this is RTH, this is VTH. Okay, so same usual, VTH will be V1 by R1 plus V2 by R2 plus V3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. So here we'll replace all these values. V1 is 12, R1 is 6, R2 is 12, V3 is 16, R3 is 4. But what will be the value of V2? So here, as there is no voltage source, we'll replace it with 0. Okay, so this will be 12 by 6 plus 0 by 12, V2 is 0, plus V3 16 by 4, R3 which is 4, and here it is 1 by 6 plus 1 by 12 plus 1 by 4. So this is 2, this is 4, this is 2 plus 4, that is 6, divided by, it will be 12, 2 plus 1 plus 3, it is equal to 6. 6 divided by 6 by 12, which is equal to 6 into 12, this is equal to 12 volt. VTH is equal to 12 volt. So the important thing here is that when we have a number of parallel voltage sources, that is voltage source in series with resistances connected in parallel, and in one of the branches there is no voltage source there, then you will have to assume, or not assume, that voltage source for that part, that specific branch, will be 0. Okay, so now we have to calculate RTH, R1 parallel R2 parallel R3 directly, 1 by R1, 1 by R2 by R3 is 1 divided by 1 by 6 plus 1 by 12 plus 1 by 4 is 1 by 6 by 12, which is equal to 2 ohms, right? Yes, it's 2 ohm. RTH is 2 ohm. So VTH is 12 volt, RTH is 2 ohm. So this current I will be VTH by RTH plus 20, which is 12 by 2 plus 20 is equal to 12 by 22, that is coming around 0.545 ampere. Okay, this is equal to I. So here the important thing to remember is that whenever you have such kind of a situation where there is no voltage source in a specific branch, then set that value, put that value of voltage in this equation as 0 to determine the Thevenin voltage. Okay, so this is the third question related to Millmans theorem, which we have discussed. So this is the fourth question on Millmans theorem, which we will discuss. So here again we have this circuit, and we have to find out this current flowing through the load resistance equal to 5 ohm. So the usual approach, excluding this 5 ohm load resistance, we have to find out the Thevenin equivalent for this part, okay, the parallel voltage sources connected along with the resistance connected in series. So it will be like this. VTH, RTH, and this. So now we have to determine VTH and RTH. So VTH here is V1 by R1 plus V2 by R2 plus V3 by R3 plus V4 by R4 divided by 1 by R1, 1 by R2, 1 by R3, 1 by R4. So here V1 is 10, R1 is 10, V2 is minus 20. So here always pay attention to the polarity. Here everything is plus minus, plus minus, plus minus. Only this 20 volt is minus plus. There is minus 20. So divided by R2, which is 5 ohm, plus 5 by 20 plus 30 by 15 divided by 1 by 10, 1 by 5, 1 by 20, 1 by 15. So that is 1 minus 4 plus 1 by 4 plus 2. And likewise this will also be. So let us directly calculate it. So it is coming around 0.417, and this will be 3 minus 4 minus 1 plus 1 by 4 is 0.25. So it is minus 0.75. So it will be somewhere around minus 1.8 volt it is coming. Okay, this is VTH. Or this is the way to write it, minus plus 1.8 volt. Minus because minus plus, this will be the polarity of the voltage source, and write it 1.8 volt. Okay, so here we have calculated VTH. RTH will be R1 parallel R2 parallel R3 parallel R4, which is directly 1 by R1, so 1 by R2, 1 by R3, 1 by R4, which will be the same here, 1 by 10 plus 1 by 5 plus 1 by 20 plus 1 by 15, which will be 0.417, 1 by 0.417, and that will be around 2.4 ohm. Okay, 2.4 ohm. So this is RTH. ohm. So here we have calculated RTH, which is 2.4 ohm, and this is VTH 1.8 ohm. direction of current will be like this, plus to minus. So IL will be VTH by 5 plus RTH, which is 1.8 by 5 plus 2.4, which is 7.4. That is equal to 0.24 ampere. This is the current. Okay. So this is the fourth question related to Millmans theorem, which we have discussed. So this is the fifth question related to Millmans theorem, which we'll be discussing. So this is the circuit here, and here we have to determine this current flowing through this 0.5 kilo ohm resistor. Okay. So the usual approach here, we have to determine the Thevenin equivalent circuit across these terminals A and P. So here the circuit will look something like this. VTH, RTH, and here we have 0.5 kilo ohm resistance. So here I have not mentioned the polarity because we have not calculated VTH. So here this will be V1 25 volt, R1 will be 1 kilo ohm, V2 will be minus 12 volt. Pay attention to the polarity, it is minus plus. R2 will be 0.5 kilo ohm, V3 will be 15 volt, R3 will be 3 kilo ohm. Okay, so don't get confused with this 0.5 kilo ohm. Do not think that 0.5 kilo ohm is R2. That is the mistake that students do. We have to determine the Thevenin equivalent across these two terminals. That's why deliberately this resistance is inserted in between, so that in order to create confusion. Up to this point we have come across questions where the resistance was at one extreme end, right hand side, but here it is in between. We have to determine the Thevenin equivalent circuit. So that is the whole point of this question, to make you understand that when we have to do something in between, when the current has to be determined in the middle branch, do not get confused, do not get confused, assign some random number R1, R2, R3 with respect to it. We have to focus on determining the Thevenin equivalent circuit. So excluding this 0.5 kilo ohm resistance, name the resistances and voltage with that serial number. So when we exclude it, this part, this 0.5 kilo ohm part, this is V1, this is R1, this is V2, this is R2, this is V3, this is R3. So VTH will be same formula, V1 by R1 plus V2 by R2 plus V3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3, which is equal to 25 by 1 plus minus 12 by 0.5 plus 15 by 3 divided by 1 by 1 plus 1 by 0.5 plus 1 by 3. This is 25 minus, this will be 24, 12 multiplied with 2, 0.5 is 1 by 2, when it goes to numerator it gets multiplied with 2, it is minus 24, and this is 5, and this is 1 plus 2 plus 0.33, so it is 25 minus 24, this is 6 by 3.33, isn't it? 6 by 3.33, or we can write it as, let's say, in order to avoid confusion, we'll write it as 10 by 3. Okay, 10 by 3 is the same thing, so it will be 18 by 10, which is 1.8 volt. See, 3.33 is the same as 10 by 3, isn't it? So that's why I wrote, so that it will be simpler to calculate. So VTH is 1.8 volt. 1.8 volt. RTH is this part, okay, 1 by R1 plus 1 by R2 plus 1 by R3, this portion, 1 by 1 plus 1 by 0.5 plus 1 by 3, which is the same thing. So that will be equal to 10 by 3 again, 3.33, isn't it? So RTH will be the same thing, which will be 1 divided by 1 by 1 plus 1 by 0.5 plus 1 by 3. Okay, so again that will be 1 plus 2 plus 1 by 3, and it will be 0.3 kilo ohm. That will be 3 by 10. Okay, that is equal to 1 by, this will be 10 by 3. It will be 3 by 10, which is 0.3 kilo ohm. Here it was 10 by 3, when it goes to the numerator side it will become 3 by 10. So RTH is equal to 0.3 kilo ohm. Okay, so now 0.3 kilo ohm, and here it is 1.8 volt, so it will be plus minus. Current will flow in this direction, which is I. So I is VTH 1.5 by RTH 0.3 plus the resistance 0.5, both are in kilo ohms, 1.8 by 0.8, and the value will be in terms of milliampere. So that is, it is coming around 2.25 milliampere. This 2.25 milliampere, because voltage unit is volt, resistance unit is kilo ohm, that's why current unit will be milliampere. So this is the fifth question related to Millmans theorem which we have discussed.